How stupid I allow myself to look for you guys. All right. Can you hear me? Okay. One of the occupations expected to have the most growth in the next few years is registered nursing. The number of people in thousands employed as registered nurses in the United States can be estimated by the linear equation y equals 46.7x plus 2,279, where x is the number of years after the year 2003. Whoa. Okay, graph the equation and use the graph to predict the number of nurses in the year 2014. Now, to actually be able to do that problem, we're going to actually need a lot more knowledge. So first we're going to go through most of this lesson. We're going to come back to this at the end. Okay? Can you hear me now? All right, this is solve x plus y equals 6. This is the first time we're ever solving an equation in two variables. It's a linear equation in two variables, and it's linear because the highest exponent is a 1, so that's the degree of the equation. Okay? When we want to solve a variable in an equation in two variables, kind of like we said in lesson 1, we need a pair of points, those x, y points. Well, this one's so simple because I can pick a pair that equal 6, right? I can go 3, 3. X is 3, y is 3. I can do 1, 5. I can do 5, 1. I can do 2, 3. No, that wouldn't work because that's not 6. I can do, because x plus y is supposed to equal 6, 2, 4. I can do 4, 2. I can do -1, 7. I could do 1/2, get my drift? I could go on like forever. How many solutions are this? And infinitely many solutions. That's why it's not good enough to just list your points, because it would go on forever. So in order to solve something like this, you actually have to show the solutions. So we're going to graph the solutions to this. So 3, 3. 3, 3 is right here. I'm not going to do all of these. 1, 5. 1, 5 is here. Okay? And then we have 5, 1. 5, 1 is right here. And then we have 2, 4. 2, 4 is right here. 2, 4. Okay? And I'm going to graph one more. And we have, let's see, I would do -1, 7, except it doesn't fit. How about 0, 6? 0, 6 would work, right? 0 plus 6, so 0, 6. Here is 0, 6. And notice these points are collinear. Linear means line. Co means sharing the same straight line. So they share the same straight line. Co means sharing the same straight line. If I graph this and I connect, I'll get a line. And I want to make it bigger and longer than my actual points. So all linear equations give you a line. And there's your line, and all lines are straight. That's the purpose of a graph. It's a visual representation of the solutions. I know that this point up here, that does not solve the equation. Why does that point not solve the equation? That point does not solve the equation because it's ugly. No, that's not why. That point does not solve the equation because it's not in a line. Only points on the line will solve the equation. Okay? So this point right here, this point is the point 6, 0. That solves the equation. This is the point 4, 2. 4, 2. That solves the equation. Points on this line, and of course fractions here, but I don't know what they are. So fractions solve this equation. So that's what this does. That's why we need a line. That's why we need graphs, to show the infinite number of solutions. That's why we put arrows in both directions, because it goes on forever and ever and ever. Okay? So let's take a look on and explain to you exactly how you graph a line. Okay, let's take a look at this. If you tell me to graph, okay, I know I'm going to have to get points. Now, this is not as easy as the last one, x plus y equals 6. I can't just come up with these points in my head. So the best thing to do when it says graph, anytime it says graph, is make a chart. Now, pick a number. And we saw this in lesson 1, that all we need is one part of the point to get the other part of the point. So just pick a number, any number you want. You might want to pick -1. You might want to pick 0 for y. I don't know. Just pick a number, any number at all. Okay? You might want to pick 2 for x. I have no idea. Just pick some numbers. And I want at least 3 points. Now think about it. How many points really make up a line? Well, all you need is 2 points, but I'm really always going to try to use 3 points to have insurance, because every 2 points, no matter where I draw them, I can make them collinear. But I have to make sure that I'm correct by getting the third point for insurance. I'll show you what I mean when I graph them. Okay? So now watch this. Now, by the way, some people graph a little different than this, but I think this is pretty easy. So x is negative 1. We get 2 times negative 1 plus y equals 6. This is negative 2 plus y equals 6. Okay, I'm going to add 2. I'm going to add 2, and I get y equals 8. Okay, so this is the point, negative 1, 8. It's okay. I know it's off my graph. It's okay. All right, watch this. I'm going to pick 0 for y. Okay, y equals 0. I get 2x plus 0 equals 6. So 2x equals 6 divided by 2. X equals 3. Okay, so x equals 3 right here. And then one more I'm going to do. Okay, I'm going to get rid of this. Okay, I got x equals 2. X equals 2. You know what I was making sure of, right? I was making sure it wasn't off my graph. It's all good. Okay, 2 times 2 plus y equals 6. I'm going to get 4 plus y equals 6. Subtract 4, y equals 2. So when x is 2, y is 2. Now, if you want to pick another number, because see, I kind of screwed up there, but that's okay. I'm going to pick another number. And it's a good thing, a good place to tell you this. I can't pick now y is 8. Because if I pick y is 8, guess what I'm getting? X is negative 1. They're like a married couple, and there's no divorce. Negative 1 is always with 8 for this equation. Okay, so I'm going to pick another number. Okay, well, I'm not going to pick 2. Hello. Okay, maybe I'll pick, I can't pick 3, maybe I'll pick 4. Okay, I'm going to pick 4 for x. And I get 2 times 4 plus y equals 6. I get 8 plus y equals 6. Subtract 8. That's interesting. I get y equals negative 2. So I have negative 2. So watch. Let me plot these points. Of course, negative 1, 8 is off my graph. So I'll go 3, 0. Here's 3, 0. Go to 3. Don't go up or down. 0. 2, 2. 2, 2. 4, negative 2. 4, negative. See, now this I can make collinear. But 4, negative 2, that tells me, yep, I'm correct because all 3 points are collinear. That's why I want at least 3 points. Okay? And now I'm going to graph this. And there's your graph. Sometimes some people will tell you that you should label your graph with your equation. That's up to you. Some teachers like it. Some teachers don't care if you do it. That's up to you and your instructor. But that's 2x plus y equals 6, and it's graphed. All you have to do is get points. All right, let's take a closer look at this equation, which we just plotted over there, just graphed. This is called standard form. Standard form. Okay. Now, in standard form, which is it's in your workbook and on the slide, standard form is the form ax plus by equals c, where a and b can't both be 0, and a and b can't be 0. That means at the same time, so they won't be both 0. One of them can be 0, but not both. Okay? So a and b cannot be 0. This is standard form. Here, a is 2, b is 1. The coefficient of y, a is the coefficient of your x, b is the coefficient of your y, and c is that constant term. That is standard form. Okay, now, sometimes we have equations solved for y or x. Y equals 3x plus 9. I might have x equals 4y plus 1. These are not standard form. This one's solved for y, and this actually has a name. We'll talk about that later. Okay, this one is solved for x. Okay, not standard form, because standard form means all the variables on one side, numbers on the other. Now, the deal with standard form is when I make a chart, it really doesn't matter which letter I pick. If I pick x's or y's, it doesn't matter if I put a number here, try to solve for y, put a number here, try to solve for x, because it doesn't matter. We just saw that. It doesn't matter on these either, but I have to tell you, if the equation is solved for y, it's easier if you pick an x. Watch what I mean. If I picked an x here, and I knew x was 1, then y would just be 3 times 1, 3, plus 9, 12. So when your variable is actually solved when your equation is actually solved for one of the variables, then it's easy to pick the letter it's not solved for. It's easy to pick a number of the letter it's not solved for. When it's in standard form, it doesn't matter, but when it's not in standard form, it's easy to pick the number it's not solved for. So here it'd be easy to pick x's. Here it would be easier to pick y's. Can I pick x's or y's? Absolutely, it doesn't matter. Now I have to tell you, if I was graphing and I had fractions in my, in my problem, I would probably try to clear the fractions as always. Some people just try to pick numbers so it works nicely with the fractions. That's absolutely up to you. Okay? So let's take a look at what we mean. Okay, these all say graph. So what we're going to do is we're going to get the points of all of them, and then we're going to go graph them. All right, so y equals 1/2 x plus 4. Now I have to tell you, you can clear the fractions by multiplying everything by 2. That's not a problem. You can do that if you like. But I'm going to tell you what I'm going to do in this particular situation. Because it's just 1/2 x, wouldn't it be really easy, just like we said before, to pick x's? Wouldn't it be easy to pick x's that were even? Because if I picked 2, and I love 0, and picked -2, watch what would happen. This would mean that y equals 1/2 of 2 plus 4. Well, 1/2 of 2, a half of 2 is 1. So this would be y equals 1 plus 4, or 5. Okay? So that's pretty simple to do. Same thing here. I would go 0. Y equals 1/2 times 0 plus 4. A half of 0 is 0. 0 plus 4 is 4. So this first one is the 0.25. This second one is the 0.04. And now we'll do -2. I'm going to erase this a little bit so I can fit that in there without going to the bottom of the board. 1/2 of -2 plus 4. Well, a positive times a negative is a negative. A half of 2 is 1 plus 4. So that would be 3. So y would be 3. So I have these points. And I have, this is the point 2, 5, 0, 4, -2, 3. Okay? That's for that graph. Now let's take a look at this graph. Well, this is solved really for both of them. Y equals x. So if I pick a y, well, let's say you see it's solved for x, okay? Let's say I pick an x, and x is 3. Well, what's y? Y is 3. How do I know that? Y equals x. So whatever y is, x is. So if y is 0, x is 0. If y is -1, x is -1, because y is x. No work. I love that. Okay? All right. So now let's take a look at this problem. Oh, let me just write in the points here. 3, 3, 0, 0, -1, -1. Okay? Sometimes you're going to have to do a lot of work. Sometimes you're not going to have to do any work. This one is in standard form, okay? Even though it says ax plus by, that doesn't have to be a plus. Okay, and yes, you have a decimal here, but that's okay. We can work with that. All right, so we're going to pick some numbers. Now, when it was solved for y, it was easy to pick x's. This one was solved for both. This one is in standard form. We talked about that before. It doesn't matter what you pick. Okay, let's take a look at this. Let's do y is 2. If y is 2, we get x minus 2.5 times 2. Which is 6, okay, which is x minus 5 equals 6, and I add 5, and I add 5, and I do get, 11, so x is 11, okay? If x is 1, I'm going to have to erase this board a little bit, so here we go. Everybody see how I got that? Now let's do 1, x is 1, now I'm hooked on 11. X equals 1, I get 1 minus 2.5 equals 6. 2.5y, I'm going to move this over. 1 minus 2.5y equals 6. I subtract 1. I subtract 1. I get negative 2.5 equals 5. Keep forgetting that y. I must hate that y. Okay? Now I divide by negative 2.5. I divide by negative 2.5. Remember, that's definitely going to be a negative because we have a positive divided by a negative. So y equals negative. Now let's actually do the division. We have 2.5 into 5. 5 divided by 2.5. I have to add, move it over once. So I have to add a 0.
and that's 2. So that's 1. Oh, it's negative. Yep, so it's a 2, but it's negative 2. You know why I was screwed up? Think about this, guys. Why was I going, oh my God? Because that can't be 2 if that's 2, because 2 is married to 11. 2 can't be married to 1 also. Okay, so here we go. It's bigamy. All right, here we go. Let's take a look at y is 0. I think we can do this one in our heads. X minus 2.5 times 0. If 2.5 times 0 is 0, so x would equal 6. So those are my points there. Okay, so ready? Let's write out the points. (11, 2, 1, negative 2, and 6, 0. And now we're going to graph these. Okay, let's graph the ones that we were just looking at, and I'm going to have to use my glasses because now we're on the table and I can't see. So we're going to graph y equals 1/2 x plus 4, and we're going to start with the point 2, 5. You had a list of those points if you want to look at them for a second so you can follow me. Okay, so the first point, again, this is y equals 1/2 x plus 4, and the first point was 2, 5. So here's 2, go up 5, 1, 2, 3, 4, here's 5. Okay, and this is 2, 5. Okay, and now we're going to graph the point 0, 4. 0, 4 is right here. 0 on x, 4 on y. Now I'm going to graph the point negative 2, 3. If you remember, that was the other point we got. Negative 2 is right here. 3, up 3. And here we go. And we're going to connect them. If we did this right, they would be collinear, and they are. They lie on the same straight line. We got lucky. Now I'm going to hope that I can actually do this correctly. Here we go. All right, so I'm going to, and we got this diagonal line. And if you'd like, y equals 1/2 x plus 4, you can label your line. And that's it. That's how you graph. No, that was pretty easy. All right, that was that first one. Let's do the second one. That second one was y equals x. And we'll talk about what points we got for that. Okay, for y equals x, we got the points 3, 3, 0, 0, and negative 1, negative 1. So let's do that, which makes sense, right? Y equals x. 3, 3, 0, 0, negative 1, negative 1. Okay, here's 3, up 3. There's 3, 3. All right, 0, 0 is the origin right here. And negative 1, negative 1. So go over to x to negative 1, down on y, negative 1. So there's your point. Again, all collinear. Now we're going to connect them with a straight edge. And again, feel free to use your Visa card and leave it on the way out. All right, I was kidding. Okay, that's it. And remember, those are the 3 points I picked, but you might have had other points, and they would just be points that lay on that line, so it's okay. And remember to make arrows, because there's an infinite number of points. Okay, our axes, our axis is not labeled. I thought I labeled all this paper, so I apologize. Even on the other one we did, the axes should be labeled, okay? I'll make sure I do that. Please make sure you do that. And again, if you'd like, you can label this line y equals x. And that's it, okay? Let's do that last one, number 3. X minus 2.5y equals 6. Remember the 3 points we got there? It was 11, 2, 1, negative 2, and 6, 0. So we're going to graph those. Here we go. 11, 2. Here's 11. Go up 2. Okay, and 1, negative 2. 1, negative 2. And 6, 0. 6 zeros right here. Look at that. Collinear points. Awesome. We're going to connect these. Notice every one of my lines so far has been diagonal. Okay. Oh, again, label your axes, x and y. All right, and there's your line, and it's x minus 2.5 y equals 6. And that's it. That's how easy that goes. And that takes care of graphing those. And remember, we got all the points first, and then we graph them. So I hope you can graph those. Okay, I'd like you to try these. These are in your workbook. Try to do these. If here you want to clear the fraction, you can. Or think about it. You could just pick a number. It's easy to pick x's. Pick a number that's divisible by 3. But if you'd rather clear, you can clear. Okay, then we'll come back, click back on, and we'll show you how to do them. All right. I'll tell you what. I'm going to clear this one just to show you how it's done, just in case you weren't sure. Some of you I know rather clear. If we clear, we get this. Okay. But in the end, if you want to label your line with it, you'd have to label it with the original equation. So it's 3y equals, you do not have to clear, but I know some of you rather clear, and that's what you have. Okay? Now let's make a chart, because it says graph. Anytime it says graph, it's really easy. You can always if you want to, make a chart. Okay? So it doesn't matter what I pick here now, because it's not solved for x's or y's. Okay? So you might want to pick an x, -1. You might want to pick a y, 0. You might want to pick an x, 0. I don't know. 2, 1, I don't know. It doesn't matter. 2. Let's just try something. Okay, it doesn't matter what you pick. That's why I stand there and go, I don't know. Okay, now listen. You're going, well, if I pick different numbers, how am I going to get the same line? You're going to get the same line because remember, when you draw a line, my points might have been these 3, but your points might have been these 3. Who knows? So don't worry about it. You'll still get the same line. So it doesn't matter. There's infinitely many points. We all can play. We can all share. Okay, there's infinitely many points on a line. Okay, here we go. When x is -1, we get 3y equals 2 times -1 minus 15, which is 3y equals -2 minus 15, which is 3y equals -17. Oh, this is going to be way too much fun. Okay, which is 3 divided by 3. Y is -5 2/3. Okay, that's going to be so much fun to graph. Okay, -5 2/3. Okay, I'm going to pick 0 for y. So far I have the point -1, -5 2/3. Okay, y is 0. I get 3 times 0 equals 2x minus 15. This is 0 equals 2x minus 15. I have to move somebody to the other side. Actually, doesn't matter who. Most of you will probably move. It doesn't matter, but so. Oh, I'm going to get another lovely fraction. Divide by 2. I'll get x equals 7.5. So this is the point 7.5. Oh, wait. I'm just having too much fun. Okay. Let's see if we got one non-fraction. Okay. X equals 2. You ready? X equals 2. X equals 2. 3y equals 2 times 2 minus 15. 3y equals 4 minus 15. 3y equals, not helping me, -11. Divide by 3. Y is -11/3 or -3 2/3. It doesn't matter. Don't worry. Okay. -3 2/3. So, you ready? I'm going to write down the points for you. Here we go. I really didn't give you the hard ones. Actually, I have to be honest with you. We'll talk about this in a minute. But had you just picked, when it was y equals 2/3 x, an x that was divisible by 3, if I just picked x's that were divisible by 3, that problem would have been a ton easier. Okay? But that's okay. Live and learn. Live and learn. Okay, those are your 3 points. Next one, it's easy to pick x's. That's what I'm going to do. I'm going to pick an x of a negative, 0, and a positive. If x is -1, I'm going to do this really fast because, look, it's really easy. -4 times whatever x is y. -4 times a -1 is a positive 4. -4 times 0 is 0. -4 times 1 is -4. Oh, I love this problem. Give me this all day. All day. Okay? Those are my 3 points. They may not and probably aren't your 3 points. Okay. Let's look at this one. Okay, here we go. Let's pick a y. Let's pick a y of 1. Let's pick an x of 0. I'm just thinking ahead of myself. Let's pick, I don't know, an You pick an x? Let's pick an x. Let's pick, I'm trying to make it look pretty, but you know what? Just pick one. Let's pick an x of -2. Okay? Here we go. If y is 1, 3x minus 2 times 1 equals 8. This is y is 1. 3x minus 2 equals 8. Add 2, add 2. No luck for the weary. 3x equals 10. Divide by 3. I get 3 1/3. Are you kidding me? Okay, x is 0. If x is 0, I get 3 times 0. That drops out. I get -2y equals 8. If -2y equals 8, divide by -2, y equals 4. All right, let's do this last one. -2 for x. X is -2. 3 times -2 minus 2y equals 8. That's -6 minus 2y equals 8. I'm feeling good. I'm feeling good. Add 6, add 6. -2y equals 14. Divide by -2. Y is -7. There we go, -7. Okay, ready? Let's write our points down. We have the point 3 1/3, comma 1. 0, 4, and -2, -7. So actually, if it's solved for a variable, it's actually easy to handle it. Okay, those are our points. Now we're going to go graph them. Okay, this is a -4, -4. So the point is 0, -4. Okay, let's take a look at the ones we were trying to do on the board. We got all the points for it. Now let's graph them. Remember, we had a lot of fractions. Okay, luckily I have my handy-dandy glasses already, so let's go. All right, -1, -5 2/3. Okay, now watch this. All right, -1 is right here, -5 2/3. I'm going to go down between 5 and 6, a little closer to -6. Don't get crazy, all right? That's it. It's in the middle of that line. And then 7, 7.5, and 0. Okay, so let's go 7.5. That's +7. In the middle of 7 and 8 somewhere. 7.5, 0 is right about there. Okay, that's the best I can do. I can't do anything else. Here we go. So the next one is 2, -3 2/3. So here we go. 2 and -3 2/3. So I'm going to go between -3 and -4, closer to -3, closer to -4. Sorry. I'm going to go right about there. And now this is a little tricky sometimes because they don't always sit up collinear because there's so many fractions. Okay, so let's do this. Let's straighten this out. Oh, not bad, even for me. All right, and here we go. I'm going to connect those points. And when I connect those points, okay, of course, here we go. And of course, I'm going to put the equation on there. If I want 2/3 x minus 5, and again, we said it might have been a little easier had you picked x's that were divisible by x. Sorry, divisible by 3, because then we could have reduced with that 2/3. Okay, and you need arrows because there's an infinite number of points that solve that equation. Okay, that's number 1. Okay, for number 2. For number 2, we have x and y axis. Now I'm going to graph this, and I have the points it's the equation y equals -4x. Y equals -4x. We got the points -1, 4, 0, 0, and 1, -4. So we're going to graph those. -1, 4. Okay, -1, 4 is right here. Okay, go over to x, -1, up to 4. Okay, 0, 0 is right here. And then 1, -4. 1, -4, go over to 1 on x, down 4 on y. We're right here. And now they are collinear, so I luck out again. Let's take the handy-dandy ruler. And that's got a pretty steep slope, doesn't it? Okay, pretty steep tilt. Steep tilt. Say that 20 times fast. Steep tilt, steep tilt. No, don't do it. It doesn't work well. Okay, now put your equation of your line. That's y equals -4x. So that's number 2. We have one more to do, and that was 3x minus 2y equals 8. Let's take a look at that one. Okay, that one was in standard form. And the points we got for that were 3 1/3. Again, a fraction. 3 1/3, 1, 0, -4, and negative 2, negative 7. So let's take a look at this. Let's make sure I label my axes. Okay, 3 and 1/3, 1. So I'll go to between the 3 and the 4, closer to 3. 3 and 1/3, 1. Got to go up 1. So we're right in the middle of those two, closer to the 3. And then 0, negative 4, 0 on x, negative 4 on y. So go to 0 and down 4. So 0, negative 4. We're right here. And now the last point, negative 2, negative 2, negative 7. So negative 2 on x, and go down negative 7, and pray, baby, that you are collinear. And I am collinear. There's negative 2, negative 7. And my dandy ruler. Connect. And that's it. And I got 3x minus 2y equals 8. And that's the end of graphing, those lines. And now we're going to head back to the board. All right, let's take a look at these. These are a little different. Remember that standard form is ax plus by equals c. We've done a whole mess of graphs, 6 now, I think 7 now, just in this lesson. And what we saw is we had questions like this, y equals 1/2 x plus 4, that we could put in standard form, or the ones that were already in standard form, like x minus 3x minus 2y, I can't remember that one, but 3x minus 2y equals 8, where standard form, this was a, because it's the coefficient of x, this is b. However, when you have these, notice that either a or b is 0, because this one could be written as x plus 0y. Not that I would, but it could be. So b is 0. When b is 0, you're going to get an equation only in x. So you're only going to see the x variable. When a is 0, you're going to only see the y. So my point is, sometimes you see both variables, and sometimes you see only one variable, even though we're talking about both variables because it says graph on the coordinate axis. So I know I need an x piece and a y piece. Now notice, all the 7 or 8 problems we've already graphed, every single one of them has been a diagonal line. Let's take a look at these lines. We know they're going to be a line because they're still variables, but there's still linear equations in 2 variables. I know that because it said graph on the coordinate axes. So now I'm going to graph this. Now we talked a little bit about this in lesson 1. In lesson 1 we said if it was in one variable, then the other variable could be anything you wanted, but that variable had to be that constant. So this says x has to be negative 5. It has to be. So I need 3 numbers. There they are. X has to be negative 5. Why? That could be anything you want. Anything you want. Now notice, when I graph that, and I think we talked about this in that lesson. My lessons are kind of running together, so I don't remember. This is the x, this is the y. X is negative 5, so we got negative 5, 3, 4, 5. We got negative 5, 0. We got negative 5, 1. We got negative 5, negative 1. We get this line right here. So we get a vertical line because that's where your axes are negative 5. Negative 5, 0, negative 5, 1, negative 5, 2, negative 5, 3, negative 5, 4. So notice when my b term, the coefficient of y, when my y isn't there and only my x is there, I'm getting a vertical line. Let's see if that happens all the time, and let's see why. Notice this has x minus 7 equals negative 3. Whenever you have one variable that you want to graph, you must solve for that variable. So we're going to add 7 and get x equals 4. That's what we're really graphing here. Again, we could do the same thing if we want, right? We know x equals 4, so we can just write 4. We can make that chart. Y can be anything. Negative 8, 0, 1, doesn't matter what it is, okay? And when we graph that, again, notice, think about why, think about it, but think about why this happens. We get 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 4, negative 8, 4, 0, 4, 1. Again, a vertical line. So anytime x equals some number, anytime x equals some number, you're going to get a vertical line. And we're going to talk about that in your workbook and in one of your slides. X equals some real number is going to be a vertical line. Guess what the y-axis is really called? Watch. This is x equals 4, this is x equals 3, this is x equals 2, x equals 1, x equals 0. The y-axis is really where all the x's are 0. So anytime it's x equals some number, if you want to make a chart, have a party, make a chart. Or you can just put that line there. So if I want to graph x equals 2, I can just go like that at 2. Of course, I have to hit the 2. Let me try that again. Okay. Well, now I have x equals 2.5, so that's okay. That could be x equals 2.5 between a 2 and a 3. That's x equals 2.5. It's a vertical line. That's all it is, okay? Very easy to graph. So you can make a chart or not make a chart, okay? Here you only see the y. If you only see the y, think about what that means, okay? I can make this chart for you. Y is 0. X can be anything I want. It could be a 0. But y, it could be a 0 if I want a 0. Doesn't tell me x can't be 0. It doesn't say anything about x. There's no limitations on x. So x can be anything. So I got x, I got y, -1, 0, 2, 0, 2, 0. I got 0, 0. It is a horizontal line. In fact, y equals 0 is the x-axis. Y equals 0 is the x-axis. So y equals 0 is not a diagonal line. It's a horizontal line. Okay? How about this guy? We have to solve this for the variable. Y is -4. We can make -4, -4, -4, and x can be anything, and I'm running out of line here. I'm running out of... Okay? Or guess what? Or I can make a horizontal line at -4. I'm going to do it here. Watch. I can make a horizontal line at -4. I can prove to you that's right. Watch. 3, -4. 1, 2. Here would be 3. 3, -4. 2, -4. Right there. So here's 3, -4. Here's 2, -4. Here's 1, -4. There's my horizontal line. So y equals some number is a horizontal line. So whenever you only see, and that's what it says in your workbook, when it says when graphing a linear equation, when a is 0 or when b is 0, that means you're not going to see one of the variables. When you're not going to see one of the variables, if x equals some number, you're going to get a vertical line. If y equals some number, you're going to get a horizontal line. You can just know that and graph it, or you can make a chart. You can always make a chart when it says graph. Okay, the other thing that your workbook says, to really understand this, is the fact that if you see one variable only, you're going to get that non-diagonal line. But if you see two variables, an x with a y, so like x plus y equals 10, x if you wanted to graph x plus y equals 10, you see two variables there, you're definitely going to get a diagonal line because neither a nor b is 0. You're going to get a diagonal line. So you should know just by looking at the equation whether you're going to get a diagonal or a non-diagonal line. If it says x equal, and this is how I remember it. If it says x equals some number, it's parallel to the opposite axis, so it looks like y. It looks like the opposite axis. X equals looks like the y-axis, so it's vertical. Y equals looks like the x-axis, so it's horizontal. Okay? So, understanding that, let's look at a couple of questions that you need to graph, so you can try the next couple. There are 3 there. The first one is x equals 0. You try those. I don't care if you make a chart or don't make a chart. Do it any way you feel comfortable, and then we'll look at it together. All right, let's take a look at this question. X equals 0, we want to graph it. We have one variable, so we know it's non-diagonal. Don't confuse this with this, y equals x. That's two variables. We did that one. That's a diagonal line. But that's one variable, so it's a non-diagonal line. Since it's x equal, it's going to be a vertical line. This is going to be a vertical line. I know that because it says x equal to. If you don't remember that, you can set up a chart. X is 0, Y can be anything. Okay, let's take a look at what that is. Remember, it's a vertical line. It's a vertical line at 0, so this is it. It's my y-axis. You actually have to go past it a little bit, and that's my x equals 0. There's 0, here's 0, here's 0, 0, here's 0, 1, here's 0, 2, here's 0, 3, and so on. So that is your graph. That's it. It's that vertical line, that y-axis. Okay, for this one, it's got one variable, so I know it's non-diagonal. I know it's got an x, so it's another vertical line, but it's got one variable, so I have to solve for that variable. X equals -1. If you want to make a chart, have a party, make a chart. But if you already know it's vertical, you don't need the chart. But if it makes you happy, make the chart, okay? But truthfully, I just know it's a vertical line at -1. So here's your x-axis, your y-axis, here's your -1. It's a vertical line at -1. Okay, done. This one, y equals -6. It's got one variable, tells me it's non-diagonal. It's y equals, so it looks like the x-axis. So this is a horizontal line. Horizontal at -6. If you don't believe me, make a chart. Doesn't matter. Here's x, here's y, 1, 2, 3, 4, 5, 6. Here's -6. You want 3 -6? I already said it, right? It'd be a horizontal line at -6. There's 3 -6. There's 0 -6. There's there it is, your horizontal line at -6. So that's it. That's how you graph them. The one variables are really easy to graph. I think it's time to revisit that challenge question. Okay, I got rid of my garb here for this question, but I'm revisiting the challenge question. This is the equation that gives us the number of registered nursing, okay? Registered nurses, I'm sorry, where Y is the number of registered nurses in thousands, and X is the number of years after the year 2000. We want to graph this. Okay, first of all, we obviously need some points. So here, I've already decided that I'm going to pick the following points, just because, well, I'll tell you why. I'll talk to you about it. I picked 0, 5, 10, 15. Yes, I picked 4. All right? Now, here's the deal. The deal with this is 0, if 0 is X, that means that is 0 years after the year 2003. So X equals 0 means the year 2003 because, 2003 because it's 0 years past 2003. If X is 5, it's 5 years past or after 2003, so that makes it the year 2008. Does that make sense? Okay? If X is 10, that's 10 years after 2003. That makes it the year 2013. And if X is 15, that makes it 15 years after 2003. That makes it the year 2018. That's what I did. And let me tell you why I did it. Because B says you want to predict the registered nurses in the year 2014. So if it's the year 2014, what is X? Well, X is 11 because 2014 is 11 years after 2003. So we want to know what is Y. After we graph it, we want to know what is Y when X is 11. That's our second question. But first we want to graph it. All right, but that's what that means. All right, so I'm going to plug all these in to this equation, and I'm going to give points for us to graph. Now, understand that all of these points, all the Y's better come out to be positive because it's the number of registered nurses. And they will. And because they do, think about this. When we graph, remember, positives here and positives here. That means all my points will be in the first quadrant. So when I graph this one, I'm going to actually only use the first quadrant, okay? So let's take a look at this. I'm going to erase this, okay? Our ultimate goal is X equals 11 after we graph it. All right, does that make sense? Because if X is 2, it's 2 years after that's 2005. We want 11 because that's 2014, 11 years after 2003. Okay, so here we go. Y equals 46.7 times 0 plus, if X is 0, 2279. All All right, now I have to tell you, I'm not going to show all the work for all of this, but this is what I'm doing. I'm plugging them all in, and of course, I get y equals 2279. I'm going to do one more, and then I'm going to give you the rest, okay? So I'm going to do it for 5, all right? X equals 5. All I'm doing is plug and chugging. Y equals 46.7 times 5 plus 2279. 46.7 times 5 is 233.5 plus 2279, and this becomes y equals, and I have to be honest with you, not many of these points came out pretty, 2512.5. Okay, so that's the number of registered nurses in thousands. Since it's in thousand, we could multiply this by 1,000. So really, this is how many registered nurses there were. Okay, multiply by 1,000, add 2, move it 3 spaces, so we're going to need 2 zeros. Okay, so we're talking about 251,200 nurses. Okay, but they didn't ask me that, but just to let you know, that's what's going on. Okay, so I did this all, I got to be honest, I did this all last night. I plugged and chugged, and I'm assuming you can plug and chug, and this is what I got. 2279 for the first one. For the second one, I got 2512, oh, we just did that, 2512.5. For the third one, I got 2746. For the 15, I got 2979.5. 2979.5. That's what I got. And it's in thousands, okay? So now I'm going to graph these. So give me a second, and I'm going to come back, and this is going to be a little annoying to graph. I obviously am not going to count by ones, okay? I'm going to come back, and I'm going to graph those. All right, this is what we did. We did this graphing problem. We did the graphing problem with the nurses, and the points we got, if you remember, were 0, 2,279, and that should be, and I should have said and, 0, 2,279, and this should be in your workbook. 5, 2,512.5, 10, 2,746, 15, 2,979.5. So, obviously, we said we would have one quadrant, and here's the new graph paper for it, and my x-axis, 2 through 20, and here's my y-axis. I went up by 100. Started at 2,000, went up by 100. I actually plotted some of these already, just because I was trying to play, but I'm going to do it for you again. 0, 2,279. That would be right about here, because remember, it's 2,279. It's bigger than 2,200, but not as big as 2,300. Then we got 5. Now, 5 would be between 4 and 6. So we're going to have to go in the middle of this line. Okay, 5. 2,512.5. That's right, going to be right over the 2,500 because there's a big span of 100 in that little box. So that's right about there, okay? And then 10, have to go to 10. 10 was 2,746, which is about here, almost right between them, maybe a tad bit lower, okay? So there's that. And then finally we had 15, which was 2,015, which would be the middle box. So up here, 2,979. So it's almost 3,000, but not quite. Now, I have to tell you, I'm going to make a line. But part of this bothers me to make a line and make an arrow. Because the problem said that that these nurses, it followed this equation. But usually, it follows the equations for so many years. Because I hate to tell you, I don't really think nursing is going to grow forever. It might, but there has been in the past a slag where it comes back and it's not growing anymore. But okay, I'm not going to concern myself with history. I'm just going to concern myself with the question. So if I do that, I'm going to plot these points and now connect them. And if I connect them, I have this. Oh, I'm going to miss that point if I don't move my ruler a little better. Okay, here we go. All right, I think I still missed a little bit, but you understand that we were guesstimating there. Okay, so there it is. There's your arrow. Okay, I'm not going to go past 0 because it was from the year 2003. Remember, it said X was from the year 2003. It was the number of years after 2003. Question B said, what would it be? What would be the registered nursing? How many would there be in the year 2014? Remember what we said about that? We said that would be X equals 11, because at X equals 11, that's 11 years after 2003, which would make it the 2014 that they need. So here's what happens to that, okay? I have to go up here, go straight up, and the point is somewhere like right here. So the point is somewhere here, which is right below 2,800. Now, what is it exactly? I can't tell by my graph. That's the problem with the graph, since I can't go up by ones. But we see it's really close to 2,800. Now, I wonder what it would really be. How could we tell? Well, what we could do is we could take the equation y equals 46.7x plus 2279, that 2,279, that was the equation, and we want to know when x was 11 what y would be. So I'm going to plug that in. 46.7 times 11 plus 2,279. Well, when I do this, 46.7 times 11 is 513.7 plus 2,279, which comes out to be 2,792.7. 2,792, right below 2,800. Look at that. My graph is not bad. Pretty perfect. But hard to get this number because we're guesstimating we're not going up by ones. So in the year 2014, which is 11 years after 2003, there was approximately 2,792.7 nurses. But that's in thousands. So I'm going to multiply this by 1,000. And I'm going to get, move the decimal 3 places. So I'm going to get 2,792.7, add 2 zeros for 2 more places. I get 2,792,700 nurses in the year 2014. Maybe I should be a nurse. And that wraps up this lesson.